everyone. I welcome you all viewers and especially dear students to this online class organized by the State Council of Science, Technology and Environment. Today I'll be delivering a lecture on coordinate geometry, which is the chapter 7 from the MBOSE syllabus. So let us begin. First of all, I will explain about coordinate system. First of all, I will consider two perpendicular lines. These two lines, they are perpendicular to each other. Let me denote this one by x, this one by 0, this x prime, y, then y prime. Okay? This x prime, this x, this line x or x prime, we called it the x coordinate, x axis. The line y or y prime, we call it the y-axis, and this 0 here in the middle, we call it the origin. And this whole system that I've just explained is known as the Cartesian system. So next, I will do coordinate of a point. This is about coordinate system, coordinate of a point. Okay. I'll still consider these two perpendicular axes, this x-axis and y-axis. So if I consider any point P on this plane, okay, let me drop a perpendicular from P on the x-axis. I'll just call Pn. I'll also drop perpendicular from this P to the y-axis, M. Okay. The distance or length Pm, we call it the x coordinate. X coordinate of this point P. Point P. The distance Pn or the length Pn, we call it the y coordinate of P, of point P. Okay, so that means I'll just call this one as x, this one as y. It can be any distance. So this P, it has coordinates x, comma, y. We usually write this one. That means this x is the distance Pn, and we write it in the first, and then this y is the distance Pn, and we write it as y. Okay. So this is the coordinate of the point P. So we usually write in this way. Okay. So now I will do the convention of signs. Convention of signs. Okay. This x-axis, x or x prime, is positive if we measure to the right of O. From O to the right of it, we measure x-axis in positive. That means it is positive. And this x-axis is negative if we measure to the left of O. Okay? So we take this one as negative. What about y-axis? For y-axis, it is positive if I consider or measure above O. Above O, this y-axis is positive. And if I measure below this O, the y-axis is negative. Okay? Also, if we see this axis, x and y, this system, it is divided it divides this plane into 4 parts. Okay, you see here 4 parts, and these parts, they are known as quadrants. The parts that this system has divided, we called it quadrants. Okay. If I were to locate some point, say P, where the coordinate of this point is xy. If I want to locate this point, I will see in which quadrant it lies. Okay, and the number of quadrants is given in anti-clockwise direction. Meaning, this one we call it first quadrant, this one we call it the second quadrant, this one the third quadrant, and this one the fourth quadrant. Okay, now if you want to locate the point P in any quadrants, we will see. Okay, if suppose this point P lies in the first quadrant, okay, lies in the first quadrant, so your x, what is the sign of your x? X is measured towards the right of O, so x is positive. And y is also measured above O in this first quadrant, so y also positive. If suppose your point lies in this quadrant, second quadrant, what is the sign for x? If you see here, x is measured towards the left of O, and so it is negative, and y is measured above O, so it is positive. Okay. If the point lies in the third quadrant, we'll see what is the sign of x. X is still measured towards the left of O, so x is negative. Y is measured below O, so it is, the sign of y is negative. If the point lies in the fourth quadrant, your x is measured towards the right, so it is positive. And your y is still measured below O, so it is negative. So this is the sign convention and the sign for any point P, and if you want to locate, you have to make sure these signs are satisfied. Okay. So now I'll come to distance between 2 points. Okay. Distance between 2 points. Let me consider 2 points, say P having coordinates x1, y1, and another point Q having coordinates x2, y2. The distance of these 2 points is just a line between, it's just a straight line between P and Q. And the formula for this distance is given by this. x2 minus x1 whole square plus y2 minus y1 whole square. Okay. So let me solve some questions from exercise 7a. We have to find the distance between the pair of points minus 5, 8 and minus 3. So to find the distance between these 2 points, you just apply directly this formula. Okay. So your solution will be, you just denote this point as your P, let P be your P be this point, and your Q be this point. Okay. So find this distance. Yeah, like this. distance PQ is just this formula. Okay. See here, this 5 is your x1. Okay. 8 is y1. Minus 3 is x2. Y2 is 2. Just put directly the values. Your x2 is minus 3 and your x1 is 5 holding square plus what is your y2? 2 minus what is your y1? 8 holding square. Okay. So just solve this one. Minus 3 minus 5 is just minus 8 holding square. 2 minus 8 will be minus 6 holding square. Okay. Minus sign, minus square will be plus, so 8 will be 64. This also minus into minus opposite square is plus, 6 will be 36. Add these two, you will get 100. Okay. Square root of 100 always get. Do remember to write units. Because why? It can be in any units. The distance between any 2 points can be in centimeter, meter or kilometer. So you just write units. Okay. So let me solve another question. So this is the question. If a point A is equidistant from the points B and C, then we have to find the value of A. What do you mean by A is equidistant from these points? Okay. Suppose this is the point A and this is the point B and this is C. So we see that if this point is equidistant from these 2 points, it means that the distance AB is equal to the distance AC. From this point, we say that from this point A, these two, from this point A, these two are equidistant, meaning that the distance from AB is equal to distance AC. Okay. So keep in mind that one. Solution. From the question itself we have distance AB is equal to distance AC. So here also you already have the coordinates. You just put directly the formula this distance. So at first your A will be having your 0 will be x1 coordinate of A and 2 will be y1, and for B your coordinate 3 is x2, coordinate P is y2. Just apply here the formula directly distance. Okay. So first it will be x2 minus x1, that means 3 minus 0 holding square plus y2 minus y1 P minus 2 holding square equal to. Again same, your A will be same as P and your C, here you take Q. Okay. That means the coordinates of C, this P you take as x2 and that 5 will be your y2. Okay. Put directly the formula here. x2 minus x1, x2 will be P, x1 will be 0 square plus y2 5 minus y1 2 holding square. Okay. So see, here also we have a square root, here also a square root. If we square both sides, the square roots will disappear. Okay. Just square these both sides, the square root will disappear. So what do you have here? 3 minus 0 will be just 3. So 3 square will be 9. Okay. P minus 2 holding square, just do the formula A minus B holding square. Will be P square minus 2AB plus B square. Okay. So here the same, P minus 0 will be just P square. And here 5 minus 2 is 3. But square is also there, 3 square. Okay. So simplify this one. Bring all these from the quantities from the right hand side to the left hand side. Okay, 9 plus P square minus 2 to 4P plus 4 side will become minus p square. And 3 square is just 9. Transfer the side will be minus 9. Nothing left here, so 0. So C. 9 minus 9 gets cancelled. P square minus p square gets cancelled. So what are left is 4p plus 4 equal to 0. Again, you transfer this 4 that side, you will have minus 4. Okay, just divide minus 4 this side. P will be minus 4 by minus 4 is just 1. So by this formula we have got the value of P equal to 1. So any question related or similar to this one, we just apply the same. So this is it for this class. Thank you so much.